Okay, so tonight we're going to move on to the next chapter. Last week we did an intro on methods and, a little bit about classes and object-oriented as a primer to let you know why are they talking about methods, but they haven't even talked about object-oriented in general. So I gave you a little bit of a background on there. So apologies if some of this is a little bit of a repeat, but this is the object-oriented in classes discussion that we would have liked to have had last week before we started doing the methods discussion. Okay, so kind of a list of topics that we're going to get into tonight. What are classes and objects, instance methods, hopefully do some example code and, put some of this stuff to Java. But when we get to talking about this, there's a lot of little corners of the room, little exceptions, little patterns, and I don't want to miss any of the terminology and things like that. When you're taking the quiz, I don't want you to see any terminology that we haven't mentioned, at least in class, and giving you a little bit of context about and a chance to ask questions. So we'll try to get into some of the details. So a little bit of a review last week. Like I said, we talked about what methods and properties are on classes, a little bit of an overview on classes and some examples. So a method is just a function that we stick inside a class. A property is just a variable that we put inside a class. You're familiar with variables and functions from, previous classes, so hopefully those aren't new. And when I say method, member function, there's other terms. You might see the book use other terms for that, but they all basically mean a function, a Java function that we put inside a class. And then variables, properties, you might hear those called attributes of a class, attributes of an object. They're all synonymous, so don't let that confuse you. The terminology all means the same thing. So when we talk about classes, when we're thinking about an object, we're talking about it in an abstract way. A class is meant to be an abstract data type. It's meaning that it's one that we create. And a class, looking at it from the outside in, class is nothing more than an object that's made up of methods and properties, which we just talked about what those were. We instantiate a class, create an instance of it, and except for the static class members, they don't require an instance. You can just specify the name of the class dot and the name of the item and access it that way. But most classes, we're going to create a new one of those. And if you haven't done any object-oriented, using the new operator is probably something new. And so we'll talk about some examples of that. We invoke methods, we access properties, and all that means is we create a new instance of the object, and we use that instance, that reference, to call the methods or retrieve the properties to use them in expressions. A client is the person who creates the instance of the object or has passed an instance of the object, and they're going to intend to use that object. Why do we do this? Well, classes let us reuse code. We're all about trying to slice and dice our code and package it in ways that we can reuse it later. And if we put all of the methods and properties of a cat inside the cat class, now we know we've got them all in one place where we can get to them easily. Just an organizational method from that point of view. And related implementations. So when we talk about the Java math class, you would expect all the math functions to be in there: cosine, sine, tangent, etc. And this is the new thing with object-oriented, is that classes can also represent a hierarchical view of objects, from abstract to more concrete as we get more detailed. So I could have a feline class, and I could inherit the feline methods and properties to create a tiger class or a cat class, depending on what concrete implementation I needed to represent. Yeah, so now we get to the fun Java part. So remember, in Java, when I create a class that is static, I say public static class, that means there's just one of those. Whatever memory is allocated, whatever variables exist inside that class, there's only one of those allocated. Doesn't matter how many times you say, I want a new one of those objects, there's still only one of those. And that's very useful. We'll see that, when we talk about actual applications, we'll see some reasons why that would be useful. As opposed to non-static, or I would call the normal classes, when you create an instance of one of those, you get your very own to use, and it has its own memory allocated to it. So if a program creates 100 instances of a class, it gets 100 copies. 100 times the size of that object has now been allocated from the memory. I don't know if the book goes into stack versus heap memory, but that might be something good to Google, the Java stack versus the Java heap. And in a nutshell, when you compile a Java program, the Java runtime has some default properties. They can be changed. That's some of the options that you can specify when you run the Java compiler. One of them is stack size. You can say, here's how much memory I want to allocate for this program stack. And what it uses that for typically, mostly, is parameters. When a function is going to call another function and it wants to pass data, it puts that data or a copy of that data on the stack. And then when it gets into the function that was called, that's how that function accesses that data from the stack. When you return from the function, that memory gets given back and is no longer allocated for that purpose, so it can be reused when another function is called. It might reuse that. Well, if you can write, we'll talk about at some point recursive algorithms where a function calls itself repeatedly by design, then that can go pretty deep. You can very quickly allocate lots and lots and lots of memory off the stack and run out of it. It's a finite resource. You can run out of stack space. And then you get a runtime error called a stack overflow. And your program stops, the JVM kills it, and you have to start over again. So it's a kind of logical error that you want to avoid if you're writing recursive algorithms. It's one of the reasons why some companies, some development managers, some teams decide to adopt conventions or standards within their organization to say, yeah, we avoid recursive algorithms in this organization, so don't use them. But they're just a tool like anything else. You can shoot yourself in the foot with it, or you can use it to do really useful things. The benefit of recursive algorithms, as we'll see, is that they're very elegant to write. In terms of readability, sometimes a recursive algorithm is very easy to understand and can reduce the size of the algorithm down to a few lines of source code relative to an iterative solution. So, but one of these things mathematically, about computer science, it has been proven that any algorithm that you could implement with a recursive solution, you could also implement as an iterative solution, which is one of the arguments that sometimes development managers or teams, organizations use to fall back on to say, yeah, don't use recursion. There's absolutely no reason why you must use it. And so we would prefer that you don't use it, knowing that we're not going to shoot ourselves in the foot organizationally by mandating something like that. As opposed to the other kind of memory, which is the heap. So anytime we're using classes, objects in Java, and I say, I want to create a new instance of this object, it's going to go figure out how big that object needs to be based on how many variables you put into that class. and it's going to say, okay, based on that size, I'm going to go out to the heap and get some unused memory that's just laying around not being used for anything, and I'm going to use that space to store the data associated with this instance of this object. And the size of the heap is much, much larger relatively. You get into, if your computer only has 4 gig of RAM, lots of times you could reasonably, logically say that you have up to 4 gig of space to allocate for objects. Much, much more liberal about how much memory we can play with when we're talking about the heap. You get into virtual memory, and it could be maybe much larger than that you've got access to. But that's the difference between the stack and the heap. Stack is relatively limited and is used mostly for local variables and things that your program needs to function, the way it was coded. And the heap is much more used for your own personal allocations of objects and data that you need, and it's less restrictive. Okay, and then I didn't make this point last time, so I wanted to make sure I listed it. Like I said, this is one of those little factoids that's over in the corners that we need to get to and flesh out. But you can define a class. It doesn't have to be one or the other. It doesn't have to be static or non-static. It could be a little of both. You can have a public non-static class that has a couple of variables in it that are static, or a couple of functions in it that are static. That's okay. It can be mixed. The portions of the object that are static, there's only going to be one of those. No matter how many copies of the object you have, there's only going to be one of those pieces of the pie. So Java will figure that out. The trick is, syntactically, if you say public static class, you've said that the class is static. Now everything in the class is static. If you just say public class, some of the stuff could be static, some of the stuff could be non-static. But if you say the class is static, everything in there is static. Okay, so classes have constructors. And what these constructors are is it's a function, it's a kind of method, but it's a special kind of method. It always has the same name as the class. So if I'm creating a hello world object, public class hello world, my constructor's name is always hello world, the same as the class. Same uppercase, lowercase, everything has to match. So you can always recognize it. The other thing is it doesn't have a return type. So where you would normally declare a function like public int get count, there's no int on the constructor. It's just going to be public hello world. Okay? Just there's nothing to return from a constructor, so the language doesn't require you or allow you to specify a return data type. And that's a good trivia question for quizzes and stuff like that. How do you specify the return data type on a constructor? Well, you don't. It's a trick question. It has other variations, just like any function. You can have constructors with no parameters. You can have constructors with many parameters if you want to, just depending on how you want to implement it, how you need to implement it, how you need it to work. But there's another couple of little caveats there. Constructors without parameters are called default constructors. Okay, they get the word default not because they took out a loan at the bank and they can't pay it off, but because if you have the classes that we've used so far, the only method that they have in them is a main function, right? They didn't have any other constructors or any variables or anything like that. It's just public static void main. And that's the function that we know our application is going to call in order to run. Okay, so there was no constructor there. Well, the class that was wrapping that did have a constructor. It was just using the default constructor. So another thing about object-oriented in Java, every class is derived from the object class. There's a class named object, and you don't have to specify it. You can't, but it is. That's just the way Java defines the language. Everything is derived from object. And so the object class has a constructor, which is just object with no parameters. And if you don't specify a constructor, you get the default one. And I don't know exactly how to say what the default constructor does, other than, there's some boilerplate stuff that Java Virtual Machine needs to have happen to allocate a new object. Like, hey, figure out how big this object is based on how many variables it has in it, and go to the heap and allocate that much memory. All that boilerplate stuff that has to go on behind the scenes before you can jump in and start using your object. That's probably some of the stuff that default constructor that's part of object does. Just something that every constructor would have to do regardless. Okay, so that's one caveat. You don't provide any constructors, you still get one. It's the default constructor that comes from object. Next caveat. If you start out with no constructors and you add one that has 3 parameters, first name, last name, phone number, those are the parameters to the constructor that you're going to have. Everybody who instantiates one of these objects is going to have to provide those values. Well, then you've just said, hey, Java, I've got my own constructor, so I don't need the default one. And so you won't get the default constructor in that case. So if you give it one with parameters, it says, great, you're on your own, you got your own constructor, you'll deal with it. Okay, that's the 2 basic caveats. And then if you provide a whole bunch of them, if you provide your own with no parameters and several other with parameters of various types and counts of parameters, knock yourself out. You can have as many of them as you want to, reasonably. And then there's this other thing called a copy constructor, and that's useful because sometimes you want to make it really easy to say, I've got this client object and I just want a copy of it. So you you have a constructor that takes a reference to itself, and you pass a reference to another object instance, and it says, okay, I'm creating myself as this new instance, and you gave me a reference to another one, so I'm just going to go to each member, each thing in that, each property in the other object, and I'm going to copy those values to my instance. So that's why they call it a copy constructor. But you have to implement it, there's no magic to it. If there's a first name, last name, phone number property in your class that your class has defined, and you create a copy constructor, then you need to copy the first name field, the last name field, and the phone number field to your variables to make sure that your copy has all the data from the other copy. If you leave one of them out, what usually happens in a copy constructor bug is later the design of your program changes and you add a couple more data members to your class, but you forget to go to the copy constructor and write the copy statements. And so now your copies don't have all of the properties. So anyway, so that's, any questions about any of those kind of variants? We're just kind of talking about, the rules of baseball here. This is how Java deals with classes and constructors. Anything there I said that didn't make sense, didn't match what the book says? Like I said, every now and then there's some subtle differences in terminology, like property versus attribute, that I have to be sensitive to, knowing that you're going to go read the chapter, and I don't want to confuse you. Here's another little variation, a little another way to handle constructors. Sometimes you don't want the people using this object to be able to use one or more of your constructors. They're only for you to use. It's perfectly valid to put private or protected on those constructors instead of public. That way, your code and your class can use them, but nobody else. Like somebody in the main function can't say, create a new instance of this object and call that constructor, because they'll say, oh, I'm sorry, you don't have access to that private method or property or whatever the error message is. Okay, so that's another thing. Sometimes that's useful just because you'll have a weird variation. Like let's say the copy constructor. Like you don't want other people to use a copy constructor, but sometimes internally you may want to. Or you may have one constructor that has a bunch of boilerplate initialization code, like go connect to a database or go, whatever internal operations that you have that you want to be done in your constructor. Then you have these overloaded constructors, one that takes a full name, one that takes a first name and last name, and the first thing that those constructors do is they call the one that has all the common boilerplate code in it, but you don't want any old person that's using your object to be able to call that constructor. You just want to be able to call it internally. So create those constructors and just put them private or protected. So that's another little variation. Okay, another variation. I know this is all getting weird, and I'm giving you a lot of facts without any practical application, but maybe one of these days you'll hear a term or you'll see a pattern used and you'll think, oh yeah, I remember Dr. Snyder mentioned that weird one. But here's one that I do see a lot, is something called a factory pattern. And I don't know if we'll do much of it in here, but out in the working world in Java shops, you will see them use the factory pattern quite a bit. What you do is you have an object and you define the default constructor as the only constructor and you make it private. Okay, wait. Then how's somebody going to create an instance of my object? If they try to say new client, if my, or new hello world, if that's the name of my class, how are they going to create it? Because if you have a default constructor and it's private, nobody can call new on the object. It'll give you an error saying, sorry, you don't have access to the constructor. Well, if you don't have access to the constructor, how do you create one of those objects? And why would you want to do that? So they have this pattern where, okay, you do that in your class, and then you create another one called client factory, another class. And this is a static class, and all it has in it is methods. And one of the methods is create client. And the create client is allowed to call that private default constructor. So what you've done is you've set up a way where that function, which is yours, you defined it, is the only place where anybody is allowed to create one of those objects. So they all have to go through there. Okay? And it's kind of subtle the way it works out, but it allows you to hide whatever implementation that you have in that class, how it's created, how it's constructed, how it's initialized. Only your class gets to see that. But you give people that static method that's a factory method so that that's the way they can create it. They can call that and it will create one of your objects and return the instance of it to them. It just kind of puts the object's construction at arm's length and lets you create a gateway to how that's done. It's kind of weird, but one of the places where that's used is in unit testing. So they've got all these different things that have evolved in these languages to support unit testing. And the philosophy behind unit testing is if I write a bunch of code and then I write test code, that when I run the program, this code will call that code and pass it certain parameter values and test what it returns in those cases. then I can set it up where I will know immediately if somebody breaks my code. Okay, if I have a method that adds two numbers together, and I write code that says pass it 5 and 3 and see if it returns 8, and if not, raise all kinds of warning bells. Okay, so it's used in unit test code to use this factory pattern to be able to configure how objects are constructed and why. I'm confident that we'll get into some examples of doing unit test code in future chapters, because I want to feather that in as we go, so that it becomes, just like with the Java doc, I want that to become sort of a pattern of how you create your code by the time we get finished with the semester. But we'll get more into that later. Okay, so lots of different variations. That's all about constructors. Another little thing we'll throw in here about when we start talking about object-oriented, and this also coincidentally happens to be used sometimes in unit testing and the factory pattern, but we're talking about annotations. And this isn't exactly code that you're writing, it's more decoration that you're adding to your code. It's in between code and comments, right? When you're running your Java program, it's not going to run the stuff that you put in your annotations. But at the same time, it's a little bit more useful than documentation, which is just somebody has to go into GitHub and look at your Java code to see what your comments are. If I add these annotations to methods, then one cool thing is the compiler has access to, the compiler generally doesn't read your comments. It strips all those out. Step one, get rid of all comments. Now that I've got Java code left over, start compiling it. But the annotations, the compiler can read those. And in this case, the first one that I'm mentioning here is deprecated. So if I have a method or a property of a class and I put this little @ deprecated on it, everything still compiles just fine. But as I compile my code and give my code to other people and they're compiling their code that uses it, the compiler will start issuing warnings saying, hey, by the way, you're calling this function that's deprecated. And so that's a way for you to signal to people that I know I wrote all these methods in this class, but this one is going away. So stop using it. Whenever you get a chance at your earliest convenience, stop calling this one. Call the replacement or the alternative or do whatever you're supposed to do regardless. And typically what Microsoft's policy is on things that they deprecate is they still work exactly the way they always have for this version, but next version, it might not exist anymore. So you've got a version to prepare for stuff that's going away. Now, the policy that you implement in your code, that's up to you. You could leave a deprecated annotation on your method or property forever if you wanted to, and they could continue to use it forever, and you never actually delete it. But, okay, so that's deprecated. Another one is overrides. We haven't really talked about, I mentioned earlier that one of the things we can do with classes is represent hierarchies of objects. Well, I wouldn't say it's terribly common, but if you have a feline class and you have a tiger class that derives from feline and a domestic cat class that also derives from feline, and you've got a whole bunch of different objects and they're derived from one another, inheriting functionality, it's not uncommon to accidentally create a new function that has already been used in the parent class. Whether it's something simple like print headings or whatever, initialize, whatever. But often you will accidentally reuse the name, and that's illegal. Because what happens is kind of like with the tricks that we can play with the default constructor, we can hide those methods where they can never be called anymore because we reuse the name. Now the one in the base class can't ever be accessed anymore. It's dead code. So to prevent us from being able to do that, that can be a really subtle, nasty bug if you hit it in practice. So what the compiler does is it says, if you have a base class and you derive that with another class and you use the same name, I'm going to make you put overrides attribute on the one in the derived class. That way you're telling the compiler, yes, I intended to do that. And then it'll say, okay, we're good. If you don't put that on there, it's going to say, hey, by the way, this function hides the one in the base class, just so that you know about it. And so putting overrides annotation on the derived method is the way you get rid of that warning, which is most likely a logic error. Okay, so, and there's a whole bunch of them, and we can create our own annotations too. This gets really useful later when we start doing things like web services and we want to provide API documentation for our web service, which I hope we get into pretty soon. We won't create our own for that purpose, but we'll use the conventions that somebody else has created with their library and their tooling. Yeah, another one is JSON serialization. When we get into accessing databases, we can take advantage of a lot of code that other people write to help us do things. Like, let's say I have this Tiger class, and I want to take this instance of this Tiger class and I want to pass it to a database engine and have it stored in the database. Well, if I annotate my object correctly, there are ways where I can just say, write this record to the database, and it'll say, okay, well, let me look at it. And it's like, okay, I see how you've annotated it here. These are the columns that I need to create in the database, and it'll automatically put that object in there for me. So we'll see some of that too, hopefully. Yeah, like I said, this is all kind of abstract at this point. I don't have any examples to show you on the next slide or anything, so it may seem like a little bit of why is he telling us all this, what does this mean, but when you see it in examples, hopefully you'll think back to this. Yeah, so I want to now pause and do some actual coding of some of these variations. So I've listed the examples up here that I want to do. Let's see. Let's do something like, I'll call my new project Client Manager. I notice that some of this stuff, like JDK, this is the first time I have used this IDE since the computer's restarted, so it's going to try to download. I don't expect any problems with it, but we'll see. Yeah, so it created it, and yeah. Let's see if I can zoom in. Yeah, I don't see the zoom in function on here. Somebody Google how to zoom in on IntelliJ and tell me what the keystroke is. Okay, so I've got this main class, but I don't want to monkey with my main class. I want to create a different class. And so I'm going to come over here in my source tree on the left and right click on source and say new Java class. And it's got this cool little wizard in IntelliJ. It's just being nice to us. So I'm going to create an object of type client. So I type client and hit enter. And no surprise, all it did was it created a public class client with nothing in it. So I want to create a Java class with no constructor. Well, this is what one looks like. So if I go back to my main function, give me a couple extra lines down here. If I say client new client, variable name, and then equals new space client. So new, just like for, yeah, Alt-Shift plus. Oh, there we go. How's that? Better? Okay. So here's my code down here. Client, give it a variable name, equals new, client, open parenthesis, close parenthesis. Now that should be a clue. When I say client, open parenthesis, close parenthesis, what the new operator is going to do is it's going to call the constructor of the client class that takes no parameters. It's calling the function in essence. So it's allocating the memory for the object and it's calling the default constructor. Easy cheesy. Now that we've talked about what constructors are, that should make perfect sense, right? Now you know the syntax for how to create an object in Java. So this was the declaration of the object, the class, and this is how I create a new instance of the class. So that's exactly what I would say. Create an instance of the client object. Okay? There's nothing more complicated than that. For a class that has the default constructor only, that's all you have to do. That's not very useful. It doesn't have anything in it. It doesn't do anything, but that's how you do it. Okay, next, Java class where we override the default constructor. So the code to create the new instance of the object is going to stay the same over here in our main function. But here in the client object, I'm going to say public client, open parenthesis, close parenthesis, and it doesn't do anything. The cool thing too about IntelliJ, it's constantly analyzing your code. We call this static code analysis, but it's already determined in the background that there's two instances of the client class or two places where the client class is being referenced, and there's one place where this constructor function is being referenced. If I hold my mouse over it, gives me some more information about it. Yeah, but it's pretty helpful. It's a really nifty IDE I have found using it for actual coding over the years. So now we've got an example of creating an object, calling the default constructor where we overrode the default constructor. So if I had something in here, private int count, I might have code in here that says initialize count. Okay. Now my default constructor is doing something, but it's still not doing anything very useful because I already put the equals 0 up here. I guess I could delete that. Okay, so example of creating an object using its default constructor where we overrode the default constructor. Next, a Java class with a custom constructor, no default constructor. Okay, so let's make this sort of do something. Instead of this, I'm going to get rid of that. That was fake anyway. Let's say I want this client class to store the first name and the last name. And if somebody's going to use this class, they need a way to initialize the first name and last name. So there we go. See, now it's complaining. There are related problems. So it's detecting automatically for me that, yeah, something's going on here. That doesn't look like a pattern that I approve of. A little judgy there. But the way to fix that is to say this dot first name equals first name. This dot last name equals last name. And I don't know if you noticed that I'm not typing very much of that at all. The IDE is suggesting, it's like all I have to do anymore is name the variable, and it infers what I may want to do to that variable as I continue to try to write code. It's one of those things where I keep telling my wife at home, man, I wish I was starting out as a programmer now with this kind of tool, because this would have made me so much more productive. Okay, so now when I come over here to the main function, I get these little red squigglies under my call to this default constructor. It says, I expected 2 arguments, but I found 0 arguments that you're passing. Well, that's accurate, because now that I provided my own custom constructor, I no longer have access to the default constructor. I've made that inaccessible to people trying to create my object. So I can't just call the default constructor anymore like this. I have to pass two arguments or 2 parameters to the call. So all the little red squigglies went away. I guess I'm doing it right. Looks good. So now we've got an example of a class that creates a custom constructor that takes 2 parameters and a main function that creates a new instance of that object, passing arguments for those 2 parameters. Easy cheesy. And I'm trying to be very deliberate about the terminology I use there so that that starts to stick too. Okay, next, a Java class with overloaded constructors. So what does overloaded mean? We talked about that when we were talking about methods. I believe, does anybody remember what overloaded means in this context? Remember we talked about method signatures? Yeah.
Isn't it when a bunch of methods have the same name?
Yes. So whenever I have multiple methods that have the same name in the same context or closure or whatever you want to call it, same block of code, same context, same namespace you might say. If I have 2 objects or two methods that have the same name, but and they have to have different parameter lists, because you can't have 2 exactly the same name and the same list of parameters, because that would be sheer duplication. But if I have 2 with the same name but with different lists of parameters, that's called overloading. We're just providing multiple flexible ways to call our method. Yeah.
If multiple methods have the same name, how is the program going to know which method is being used?
Great question. So Java has a set of rules that are called disambiguation rules. So there's a set of rules for how to determine which one. So first it's going to say, well, let me look at I'll eliminate, if I'm passing 2 parameters to this function, I can eliminate all the ones that don't have 2 parameters. Now you're down to all the function calls that have, or all the function definitions that have 2 parameters. Then it starts looking at the type of each parameter. In this case, I'm passing 2 strings. They're 2 quoted strings. So first of all, I'm going to look at all of those functions that have 2 parameters and see if there's one that has string and string. Oh, great, I got an exact match, right? But say those were numeric. Well, now I don't know whether I meant to call the one that's defined as a double or an int or a float or a short. So it's got a list of rules where it's going to try to say, well, which type fits best what the person's trying to pass, and it'll just keep going down the list until it finds the best match for it. So we call that the disambiguation rules, and I think they talk about that in the chapter, either last chapter or this chapter 1, I don't remember. Or you can just Google it, Java disambiguation rules. But there's a prescribed order that it goes through to figure that out. Good question. Okay, but in this case, I've got one constructor that takes 2 strings, and I've got one call. So in order to do this other example of a client class with overloaded constructors, I'm going to have to create another constructor at least. So let's say I create a public client constructor. Okay, and now I've got one that just takes 1 string. So in my head, my own disambiguation rules, I've now got 2 constructors with the same name, and I've got one call here. I can disambiguate pretty easily myself which one it's going to call. It's going to call the first one because it has 2 strings, and it's not going to call this one because this one has 1 string. But now I've got the challenge of how am I supposed to implement this? I have a first name field and a last name field in my object, but they're just going to pass in full name. What am I supposed to do with that? Well, I could, I guess, parse it. So if they type first name space last name, I guess I could parse it. So let's see, yeah, that sounds reasonable. If full name contains a space, then, yeah, I could do that. This thing is so dang intuitive. I want to do it a different way. Parts. Oh, I guess I need to put the, oops, if I could type, equals full name dot split. So I'm going to split it into multiple parts at each of the spaces. Then I'm going to say this dot first name equals parts 0, and this dot last name equals parts 1. See, I didn't even have to type any of that. All I had to do is declare the array, and it just already assumed, oh, you probably are going to do this the way where you split it on the spaces, and then it just knew it already. It's just no fun. I guess I shouldn't feel so bad about it. I guess I feel more badly for you all, because I know that all these AI algorithms have been created sampling all the code that has ever been written and submitted to GitHub, for example, and they're extracting all the patterns for code that they've seen before. And there's probably 8 million Hello World GitHub repositories out there under different accounts, and same thing. This is not the first time anybody has ever been, had the brilliant idea to use regexes to split the string into 2 parts. So it's just somebody else has coded this before, and that's the only way the AI is able to guess that that's what I want to do now. So, Okay, so that initializes it, but what if it doesn't contain a space? Now this is another interesting little caveat about constructors. Like we said before, constructors don't return a value. It is always just assumed. If I call the constructor, it's going to create an instance of this object. Now, it may not do it correctly. You may have logic errors in the way you implement your constructor. But it's not, there's no way you can return true or false based on whether the full name had a space in it or not, right? You don't get that option. So how can I signal to the person trying to create one of me that it didn't work? You can't continue, you can't proceed, something logically bad happened. And we haven't talked about How about an illegal argument exception? So I could do that. That's not considered bad form, I guess. I can't return anything, but I can throw an exception. Now, if somebody tries to call me and doesn't give me something that has a space in it, I just throw an exception and I make them pay dearly for it. So this would be a reasonable implementation of my overloaded constructor. But you see, I still have no usages. Nobody's calling it yet. So let me go back over to my main function. And okay, so instead of passing it two strings, I can pass it Mark space Snyder, and now I get, well, it hasn't built it yet. It's still saying no usages. Not exactly sure when IntelliJ decides to refresh this. See if I can run it and get it to, wait, no! Mark directory as, well, it's marked as source as root. Oh, I bet this is that thing where it doesn't know about the JDK. That's the reason why I'm not able to run it yet. I'll have to fix that at some point. But, yeah. So this is the example of an overloaded constructor, meaning I have multiple constructors with the same name, but with different parameter lists. And I can call either one of them. So now, depending on what my needs as a programmer are, I flexibly have multiple ways to create an instance of this object. But I can't still call the default constructor because I haven't provided one. And since I have at least one constructor with parameters, I don't have access to this. I can go over here though and create one. Let's see, public client with no parameters. You know, just set it to blanks. Or, you know, maybe use the ubiquitous John Doe. Yeah, so if you create an instance of this object and you don't pass it any parameters, it's just going to assume that you want the person to be named John Doe. Pretty cool. Okay, the last one is one of the weird ones I talked about, an immutable client class with a copy constructor. Let's see what that looks like. All right, so let's do the immutable first. So I've got these two properties. So if I want to, I can create these objects, and then I can say nothing client dot first name equals Fred. I can modify the client after I created it by accessing the properties directly, because those are public properties of my class, and They're variables. I can create them, I can modify them however many times I want to. It's my instance of that object now. But if I go over here to the client, and instead of public, I say, let me make those protected. And does anybody remember why I switched it to protected and not private? I think I mentioned that before, what the difference between protected and private is. Anybody remember that?
So maybe class can change that.
Okay, yeah, and this won't really make any sense, or you won't have a practical example until we're doing inheritance, like the feline class and the tiger class and the domesticated cat class. Until we're doing that kind of hierarchy of objects, it won't make as much sense. But private means nobody outside of this class can see it. Protected means if you're a derived class from this class, you can see it. That's the main difference. So I usually default to protected unless I need to make it private, just so I don't, I've had too many cases in the past where then I need to have access to that in my derived class, and it's like, shoot, now I have to go back and change the code to give myself access. So it's just easier to move from public to protected as opposed to going all the way full breaks to private. And there's also package protection, which that factory pattern that we were talking about earlier, that relies on the package. So you can give that factory class access to these methods, even though it's not in the same class. It's part of the same package, so you can let it see it. Okay, so now these are protected. So if I come back over here to my main, I don't have access to these anymore. Ooh, it's letting me do it now. It must have finished whatever it was doing trying to configure this, because it's now letting me compile it. Oh, interesting. I'm getting wrong number of parts. Really? Let's debug this and see what's going on. Got it. Oops. Step over. Okay. We're going to go into this, step into. If full name contains space, yes it does, split into parts. Oh, anybody see my logic error here? I just realized what it is. So I correctly get the two parts out of it, but then I fall through to the throw anyway, in either case. So I need an else here. Okay, now it won't do that. Okay. So now I'm back in here. That's the other thing I just realized too. Before, when I was trying to hit this run button, the file that I was looking at was my class, my client.java file. If I go back to the main Java file, then my play button comes back. I'm going to comment out this stuff too. Actually, I'll just delete it because I don't need any of that stuff for my example. There. Now it's just my class code. Okay, so I'm going to run it. Yeah, and it worked. Why? This shouldn't have worked. I made those protected. I shouldn't have access to those variables. That's really bizarre. Build. Yeah, it should be giving me a compiler error on this, saying that I don't have access to these variables here. That's weird. Okay, that's bizarre. I should not have had access to those with protected class. If somebody figures out why that was letting me do that, let me know. There's the table in the book, I think that it showed what you have access to for the default protection, the private protection, the public protection, the protected protection. If somebody sees that table and understands why this happened, let me know. Because that should have broken with protected also. Interesting. But now that I changed it to private, after I clearly lied to you, now I'm getting the error that I intended to get. So now I have made those not accessible. Well, if I'm not able to do this now, that means once I have one of these objects constructed, it can't be changed anymore. So in essence, it's immutable. I now have an immutable client class. It can't be changed. It can be initialized in the constructor, but then that's it. There's no way to change it. I don't have any way to access a property or a function, nothing, to be able to change it. So now I want to illustrate the copy constructor, because now that I can't change this, what makes sense is to have a client, and I take a client reference to a copy. And see, it's already suggesting the code that I need to write, but it's not like rocket surgery. So there we go. So I just copy the first name and the last name field over, and I've got a new instance created from the first one. So to use that, I say client my copy equals new client, and I'm going to pass it one of the other ones. So I'll pass it another client. And so now I have a new copy with the exact same values of what its copy was. So now I have 4 variables: new client, another client, nothing client, my copy. So like I said, this all gets allocated in the heap memory. So in the heap, I should now have memory allocated 4 times the size of a client object, 4 unique individual instances of this class in memory. Another thing that we mentioned last time was the garbage collector, and when these things go out of scope. So as soon as the code executes these lines and then it gets down to this closed curly brace, all of these variables go out of scope. They're no longer accessible. The garbage collector notices that now it's got these 4 objects sitting out there on the heap, but no references to them. And boom, 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 it reclaims them. And now we're back to the starting point in terms of how much heap memory we're using. Pretty cool. Yeah, and other than just knowing the terminology and what these things are called, and knowing that you can do it, it's really not that hard. It's just variations on a theme. Any questions about those variations that we looked at? Okay. Next, so properties, like we talked about methods being just functions that are part of a class, properties are simply variables that are part of a class. My first name and last name members are data members, variables, properties, attributes. That's what we were talking about there. So another way that I can implement properties or attributes of a class is this pattern where I make the variable inaccessible to people using the object, like you saw me do, and then I create what we call a getter or setter. And I think the book uses the term mutator and accessor, but they're just synonyms for the same thing. And so, it's not, you can call these getters and setters anything you want to, but there's kind of a convention. You use the lowercase get or lowercase set, and then the name of the property. It's a convention. It's a positive pattern that you can use. So let's do that to our class. Let me see, I can probably get rid of some of these constructors. Don't need them anymore. Yeah, because that's one of the things, if I wanted to, in my main function, if I wanted to create one of these objects, and then I wanted to print oh really? There we go. Clean this up a little bit. So if I want to print this, I can't, because my first name is now private, like I made it. So to fix that, I could just go back and make this public again, or I could create getters and setters. And it's nothing but a function. See, it's already suggesting the code to use. Public string get first name. And all I have to do is return first name. If I want to set the first name, public void set first name. There we go. So now I've created a getter and a setter for first name. So now I've given the people consuming this object a valid way, of structured way, a regulated way, if you will, of changing the value of that property. In C#, they actually call these properties. VisualBasic.net, if anybody remembers that, would actually declare it public property. And so that's a proper label for what these are. But here, they're just functions. They're functions we happen to name a certain way that we recognize as, oh, that's probably the way I set the first name property. And we know that we're following this pattern of declaring a private variable and having a function to get it and a function to set it. So we're referring to that as a property pattern that we're following there. But there's nothing that regulates it. So now, instead of just accessing the variable name, I can access the getter. And then I can do the same thing for last name. Can I actually show context actions? And looky there in the menu, it says create getter and setter for last name. I don't even have to type it. And it just does it all for me. Now, in the strictest sense, you might say, well, isn't that using AI to do my homework? Well, in my career, in my day, we wouldn't call it using AI. We would say, I know what I need to do, and I'm using a wizard to help me do it. It's just doing the typing for me, but I know what I needed to do. And just a memory aid to remind me of what the syntax is. I mean, I'm splitting hairs here a little bit. It's a fine line. But I'm walking a fine line because I want you to understand what needs to be done and what the code means when you see it. I want you to be able to know that you need to create it and how to do it. But I also want you to be productive developers that can be hireable and be productive and exceed the productivity of the new hires that they're getting from other schools, because I want you to be more efficient and more fluent at being able to use these tools. IntelliJ is an awesome tool. It has really cool features. I want you to know how to use it, and I want you to know how to code without having to use it. So it's a fine line. So now I have a getter and setter for both. So if I want to do both variables, there. Yeah, I'd already guessed what I wanted to do. All I had to do was type space. And I knew that's what I was probably going to do. Just crazy. Let's see if I run it. Yep, and it prints Joe Bob. So it created a new instance of the client. It called the constructor that takes two strings. It set first name to Joe. It set last name to Bob. And it returned the new object instance to new client. Now I've got new client that contains an instance or a reference to an instance of an object. And I can say use the getters for get first name and get last name to access the values in those properties and print them to the screen. Pretty nifty. And the thing I want to point out too here is by adding all of these getters and setters and making them private, and I mean, it seems like a lot more code than just making these two strings public, right? But it's just code. This object doesn't require any more memory to house this object instance than it did before when they were just public variables. So you add all the getters and setters that you want to make your code look as elegant and be as convenient to use for consumers as you want to. Knock yourself out. It's not going to increase the size or the complexity or the runtime of your code in the slightest. The only thing it may do is that bytecode file, that .class file that you get when you compile your Java file, may be a little bit bigger. Sue me. Yeah, It's just a different style, just a different way of doing it, a little bit more elegant, a better pattern. Yeah, and this is the cool thing. Now that because it may seem kind of silly, it doesn't provide any extra functionality over just having a couple of public variables. However, now I can control access. So for example, I could say in my setter, in this code right here, it's funny, it's not smart about how I want my code formatted. I could say something like if, what is it, length? Yeah, first name dot length is greater than 10. Throw new illegal argument exception, first name is too long. Now I've got a way to validate the input. So now if somebody tries to use my object and they try to make the first name too long, I can prevent that from happening. Which lets me write all kinds of other, maybe that's a little bit of a silly example, but it lets me write other code throughout my class that can rely on the fact that the data validation for this property has occurred already, and I don't have to duplicate that validation every time I need to do some processing with it. So that's the beauty of having these getters and setters instead of just using the raw properties. The other thing that's powerful about that is, what if I thought, you know, it would be a lot more efficient if instead of storing the first name and last name, so version 2 is going to come out, and version 2 is going to just store the full name in one string instead of two. So you can see I just created a whole bunch of red in my code, right? All right, so if I'm going to have a copy constructor, or I mean a constructor that takes two parameters, I can do that. I can handle that. I can initialize my object that way. So I'll just concatenate them together with a space in between and initialize my full name internal property that way. Now this is a little tricky. How do I set it by just being past the first name? Well, I have to get clever with it. I have to split and I don't have to put this everywhere, especially, you know, if it's not ambiguous, there's not another full name that I could be referring to. I'm just trying to be a little bit pedantic about it so that you know I'm talking about the data member, the variable full name, not the parameter that's being passed in here. So I'm going to say this dot full name equals close. It was pretty intuitive. First name plus parts 1. So I believe what that does is it takes whatever was the first name in that full name and it replaces it with what they just told me. And I could do the same thing with the last name. And I would have to do that with the getter also, parse it, and then return it. Now it seems to me like, yeah, I saved a variable name, but I'm having to add a whole bunch of code to the getters and setters to make this work. And, you know, you be the judge whether overall that's going to end up being a better implementation than having them split out of my object. Yeah, that would probably be correct. But you can still do it. But the point is, the overall point here is, I decided that I wanted to change the internal implementation of this object, the way it was representing that data. And the main code didn't have to change. So I would say the public contract that I established for this object with its public methods and properties did not change, even though the internal implementation of that object changed quite a bit. And that's one of the beautiful things about using getters and setters and not giving people access to the raw internal data members, is that you have that flexibility later. So that's the big point here. That's why it's a better pattern. Okay, what's next? Yeah, we already did that. Okay, another thing, again, this is mostly terminology again. So Java, the language, has 8 built-in data types. We've already talked about that like 2 or 3 weeks ago. That's the list of them on the screen. You know, nothing new here. We already know those. We can use any of those anytime we want to. We can declare variables of those types. But those are the 8 built-in data types for Java. Then additionally, there are a whole bunch of what we would call built-in. They're not necessarily built-in classes, but they're classes that we didn't have to write. We as Java developers, even for the simplest little Hello World application, we get all of these free classes, like the math class. It has all the definitions of pi, the definition of cosine, sine, tangent already. We don't have to do those. It has integer.parse. It has system.println. You know, we don't have to invent those. They're already there provided for us. And so we would call those built-in classes, generally. Then the classes we're talking about now, where we say public class client, that sort of thing, the examples we've been working through, those are programmer-defined classes, or, you know, custom data types. You know, they're still data types, I guess is the point. All of those, the 8 built-in, the ones provided by Java, and the ones we create, they're all data types. And anywhere you see syntax of Java specified where it says you can use a data type here, your classes are also data types. Yeah, so I said the new operator creates it. You have to manage these references. You saw in the example I had 4 different variables. Each one of them referred to an object. Let me show you another little example here. Let me see if I can back up before I messed up my class with that full name stuff. Undo, undo. Okay, there we are. I think I'm back to having a working object again. Okay, so I have this variable called new client, and I created an instance of it. But if I come a few lines further down and I use the same variable, you know, let's say that I successfully used that variable for what I wanted to use it for. Now I'm going to reuse it. New client equals new a different value. And then I want to print that. It's perfectly fine. It's my variable to do with it what I want to. However, when I get to this line of code and I assign this variable a new value, you know, this is no different than if I had said count equals 5 and then said count equals 6, right? I'm free to do that with my variables anytime I want to, depending on the logic of my program. It's perfectly legal. However, when I assign new client to the instance of this second object that I created, what happens to the first object that I created? Any guesses based on what we've said earlier? Yep, it goes away, and I don't have access to it. And the memory also is going to come to the attention of the garbage collector, and it's going to say, hey, I've got this object on the heap, and there's nobody referencing it. The number of ref counts just went from 1 down to 0. So it's going to wake up and it's going to grab that memory and it's going to free it up. So keep that in mind too. In certain cases, like in multi-threaded examples, you have to be very careful about losing the last reference to an object and it goes away, and then some of your code tries to access it again, and then poof, sorry, you did something bad. Your program's now going to go away. Sit in the timeout box. So that was what I wanted to point out. When you lose the reference to the object gets reclaimed. We talked about the this reference within that class. Using that this keyword refers to that instance. Yeah, and that's true. I mentioned this earlier when we were talking about the default constructors. So one constructor can call another constructor. So you can put a bunch of common code in one of them and have the other ones call it. But there's some caveats there. First of all, you need to remember that it has to be the first statement in the other constructor. If you're going to call one of the other constructors, it has to be the first statement. And that has to do with just the way Java compiles constructors. It has to wire some stuff up there, and it needs that to be the first. It's not necessarily because of the way you have to write your code, it's the way it has to write the bytecode inside. Okay, another thing to know about Java, libraries. So when we talked about the math class, one of the Java provided classes, that's an example of a library. The Java.lang, those ones, the math class, the integer class, etc., all those that I was talking about, the implicitly imported ones you get for free. The other ones, you have to explicitly import them. And all you just do is say import in the class. So if I want to do some math stuff in here, and you have to do it in each one of these. So if I like say import I think math is, yeah. So import java.lang.math. So what it's talking about here is I explicitly use the full name of the math class. And it said, yep, I know what you're talking about. I'll import it. Now you've got access to math.py and everything else. I don't know if I could just say import math. No, it's not going to let me. But if there's classes defined in there, like some of these libraries have classes inside them, if I import the library name, I get for free all the classes inside there, and so I can import just the class. I can import the entire fully qualified path and class name. I can import the package that it came from and say, hey, I want asterisk, I want everything in there. That would be like import java.lang.star. That's legal to do, and now I get all of them. Generally, you don't want to do this unless you really intended to, because it can pull in extra stuff and make your bytecode bigger. Yeah.
What is a package compared to a class?
So the package, so my class, this client class, belongs to the, well, it's called Client Manager because that's what I named my
So that's the package.
project. In this case, yeah, like if somebody not part of my program imported mine as a library, they'd call it Client Manager dot client.
That's why the protected was working. It's because it was in the same package.
So it was package protection class. Okay. I suspected that, but I still think that protected should be not package scope. I don't think it works that way in C++ or C#. I know it doesn't in C++, but I don't think it works that way in C# either. But anyway, thank you for letting me know that. Here's another example of some objects that are out there that you can use. There's a local date class. So if you need to do any date and time handling, you know, hey, what day of the week is, January 12th of 2026? You could create a local date instance, set it to those properties, and get the day of the week property back out of it. So it has a flexible set of getters and setters where you can set parts of it and then get other parts of it, and handle dates and times like that. It begs a question, what is the internal representation of the date inside the local date class, and whether we care or not. Because the cool thing is some other Java developer wrote that class and implemented all those getters and setters. So we as consumers, so me as a Java programmer, if I want to write a program using date time logic, is it important to me that I understand the internal representation of that data? Like, is it stored as full name or is it stored as first name, last name? Do I care? How about this? Can anybody think of a reason why I might care how it's implemented internally? Thoughts?
To do like we did with the first name, if you want to know the first name or the month or something.
Okay, well, in the example with the client object, you had all the exact same functionality either way. Let me pose an example that's specific to the date and time. If I created an instance of a local date object and I said, set it to, January 1st of 2024 at 8 o'clock and 0 seconds. And then I said, add 7 days to that object. Is it going to take into consideration leap years? Is it even going to take into consideration how many days are in each month? I hope so. But with date time specifically, I know one of the things that I ran into working on Windows is, depending on which part of Windows you're talking about, there are multiple implementations of date time classes. And this data gets passed back and forth. So in the raw system, in the CPU, the clock is simply a 4-byte value. It's like defined to be the number of milliseconds past some Oracle date in the past, like 1971 or something like that. And they just count how many seconds past that it is. Well, if you want to know what day of the week it is from some large binary, hex number, you're going to have to do some calculations there. You're going to have to figure out, okay, what year is it? What month is it? What day is it? And is that a Sunday, Monday, Tuesday, or whatever? All that processing is going to have to be done there. But there are other places where, we don't care about any of that. All we're caring about is the year, month, day, hour, minute, second. And we don't let you add 7 days to that value. That's undefined. We don't have such a function. If you want to do that, then you're going to have to use a copy constructor, do the math yourself, and create a new date time object that has the new value that you want to use. So there's all kinds of different implementations depending on where those values are being used and how they're being used in the program. So the answer to this is maybe. It depends on what the object is and where you're using it, and what you need to do as to whether you care about the internal representation of it or not. You may have to go seek smarter object, or you may have to write it yourself. Another thing about object-oriented stuff, I think I'm getting close. Yeah, I've only got a few more slides left. Composition. So when we're talking about the hierarchical representation of abstract objects using classes, we refer to the relationships between different objects. Like if I'm talking about the relationship between a feline and a tiger, I would say a tiger is a feline. If I have two tiger objects, this tiger is one of this object. You know, class-wise, they're the same, or one is a parent of the other, so it's an is-a relationship. As opposed to if I have a class that's called zoo, then the way I might implement that is I have variables, you know, like with my example of the client, this client has a first name, and it has a last name, and it has a full name. That's a relationship between the client class and the string class, okay? And we would call this composition. The client is composed of a first name and a last name attribute, as opposed to, you know, the tiger is a feline. So the feline doesn't have a tiger. The tiger is a feline. That's the difference in there. Just terminology. It'll make a lot more sense when we're actually talking about inheritance at some point. Yeah, and this is the main thing analysis-wise, is if I'm implementing a zoo class, don't be putting code that's specific to a tiger in the zoo class. Create a separate tiger class and put all the tiger-specific code that's just about tigers in the tiger class, and then create an instance of the tiger class in the zoo class. People that are new to object-oriented make that mistake all the time. It's no penalty to invent a new class and put code specific to that class in that class and reference it from some other class. That's perfectly fine. But it can be problematic to put code that's not, they call it sort of the single purpose principle. An object should only have stuff about that object in it. And if it's about some other object, put it in that object. Don't mix them. Likewise, yeah, we talked about inheritance, same thing. You know, if we've got things that are common to all of the different subclasses, we would put those in the base class, and we would reference those from the subclasses. It's a way of reusing code. We don't have to duplicate the code in the cat and the tiger class. We can put it up in the feline class, and both of them can take advantage of it. And we'll get to that later. Okay. Any questions? Did I beat that topic to death?